only rotated around the origin, so now we're going to take a look at what it looks like to rotate around a point that is not the origin. Okay, our center of rotation can be anything, any point. It doesn't just have to be 0, 0, okay? So we're going to go 90 degrees clockwise on number 1, 90 degrees clockwise, about 1, negative 1. So first things first, we're going to make a dot at 1, negative 1, so we know what our rotation, our center of rotation is. Boom, and it's right there. So at this point, you can kind of imagine that the axes aren't there, right? If we were just somewhere random in space, this would look no different than us rotating around the origin, right? It only looks a little bit funky because of those axes there. We're going to go 90 degrees clockwise. Is that turning over to the right or turning over to the left? Right. To the right, this way, right? So just like before, I'm going to turn my paper once to the right. All right. Now, like we said, it looks like my shape should end up in which quadrant? Quadrant 4, right? Now, this go around, it is going to work. Sometimes it's not going to be that easy. So, I don't want you to think of that as 100% accurate all the time. It just depends on the situation. So, what we have to do now is, this origin does not exist. Pretend that the axes are not there. Can you guys kind of visualize that the axes aren't there? Okay. This is just a triangle and a dot floating in space with no reference. What I'm going to do now is I'm going to find my coordinates for A, B, and C. But I'm going to write these coordinates imagining that my reference point here is actually the origin. Okay? So we're doing the same thing we did yesterday, except instead of using the origin, we're using this new point as a pretend origin. So from my pretend origin, what would the coordinates of this point A be? 1, 2, 3, 4, 5, 0. 5, 0. From this pretend origin, what would my coordinates for point B be? 2, negative 1, negative 2, negative 3, negative 4. 2, negative 4. Yeah? Am I sure? I think so. What about point C? 2 what? 2, 0. This is my origin. 2, 0. Everybody with me so far? The weird part's coming up right now. Okay? You're not with me? Or kind of? Okay. What question can I answer before we take a step forward? Anything in particular? Maybe when you see it, it'll make sense. We got 4 of them. It'll make sense at some point. Now that we've got our reference coordinates, we're going to turn it back around. Okay? Now, we are not actually plotting these 3 specific points. 5, 0 would be right here, right on the x-axis. We're plotting these points in reference to the center of rotation. So again, it's my pretend origin. If I'm pretending this blue point here is the origin, and I wanted to plot the point 5, 0, from this point, I'm going to count how many spaces to the right? 5 of them. 1, 2, 3, 4, 5. There's my point A prime. Again, if I'm pretending this blue dot is my origin, and point B prime is at 2, -4, what direction am I going to move and how many spaces am I going to move it?
2 right.
I'm going to go 2 right, and I'm going to go
4 down.
4 down. 1, 2, 3, 4. Notice how this point is not at the real 2, -4 on my graph. You guys see that?
Yeah.
It's kind of like what we talked about. We're not really writing the coordinates. We're more so writing a vector of 2 directions. Positive x means I'm going right. Negative y means I'm going down. That's more so what it is than a point. C, I'm going 2 spaces to the right, 0 spaces down from my fake origin. 2 spaces to the right, 0 spaces down. There is C prime. I'm going to connect all 3 of those together. All right. Everybody see that? Okay. I'm going to show you guys a fun little way to check to see if this works out, okay? If I draw a point from my pre-image point to the center of rotation to my image point, let's see what happens. If I have point C right here, and I draw a line from that pre-image point to my center of rotation, like this, and then from that center of rotation to my corresponding image point like that, what type of angle did I just construct? A right angle, a 90-degree angle. It's almost like we rotated this 90 degrees. Everybody see that?
Yeah.
All right? Because A is on the same line, it's going to be the same thing, but I'm going to go over to B. If I draw a line from point B to my center of rotation, then from my center of rotation to my corresponding image point for B, what type of angle did I just make there? Another right angle, a 90-degree angle. So if I finish my 90-degree rotation and I connect my pre-image to my center of rotation to my image and it does not form a 90-degree angle, something must have went wrong. Okay? So this is a way for us to check to see if what we graphed is correct. It is not something you have to do. It's just something that is helpful when you're getting started. Tyler.
Would you present like 1 negative 1 is like the origin instead of like, yeah?
What do you mean?
Then there's like an axis, like negative, 1 negative 1.
That's exactly what we did. Right? If this is the origin and I'm plotting 5, 0, then yeah, I'm pretending that this line is the x-axis and I'm going 5 spaces over, 0 spaces up and down, writing A prime, right? So if you want to think of it like that, you can. If you'd rather think of it like a vector, that works too. It's up to you. I can't control your thoughts as much as I would like to. All right? Give me a quick show of thumbs. Does that sound okay with number 1? Yeah, kind of. It's weird. I understand it's weird. I don't expect your thumb to be up just yet. Let's see what's going on with number 2. Number 2, I'm going to rotate 90 degrees counterclockwise. About the point 2, 0. Right? So what that tells me right away is that my origin essentially, you can think of it shifting over to the point 2, 0. That's going to be my new reference. So make a dot at 2, 0 real quick. All right, we made our dot at 2, 0. That is right here. Okay. Counterclockwise, we turning over to the left or turning over to the right?
Left.
Turning over to the left. So I'm going to turn my paper over to the left one time like this. Now again, this is what I was talking about. It looks like our shape is going to end up completely in the second quadrant. But that's only if we're using the origin as our center of rotation. Because my center of rotation is not the origin, we're going to see how different it is. It's just a little bit different, but it is different. Okay? I'm going to make my vectors here for L, M, and N. If this blue dot is my origin, and like Tyler said, I'm pretending this is the x-axis, I'm pretending this is now the y-axis, what would the coordinates of this point M be? Negative 2, 0. What about L?
Oh.
Negative 2 what? Yep, negative 2, positive 3. And what about N? Negative 5, 3. We okay with how we got those little coordinates / vectors? Yeah?
Yeah.
Alright, I'm going to turn it back around and I'm going to plot those points, pretending once again that this blue dot is my origin, starting with L prime, 2 spaces to the left, 3 spaces up, there's L prime, M, 2 spaces to the left, 0 spaces up, there's M prime, N, 5 spaces to the left, 3 spaces up, there is N prime. Right? So it doesn't look as like mirrory or symmetrically when we rotate. It is still up in that second quadrant, but it's turned in reference to 2, 0, not 0, 0, right? And we can kind of see that. If I took my little slide here and just wanted to give you a little visual of what we're doing. Here's my little triangle. Here's my center of rotation. And I'm just turning it on that center of rotation until it matches right back up. Boom. There's my image shape. Yeah? Now, if I was taking this shape here and I rotated it around the origin, then I'd be turning it around the origin. And you see how it's further up in that top left corner, just like it's in this top right corner. That's what I mean when I say a little bit more mirror-y, more symmetrically. But that's because we're used to seeing a rotation on the origin. It's not always going to be that way. If I go back to the first one, right? Here's my new center of rotation. There's my triangle. If I go 90 degrees around that center of rotation, it means I'm turning on that point. Boom, I line right back up where we saw. Okay? Is it kind of making a little more sense the more we see it? Yeah? Hopefully? Okay. Okay, whatever. That's beautiful. All right, number 3. Let's go 180. Let's see what that looks like. 180 degrees around 3, negative 1. So pretend I'm rotating around the origin, right? And I'm going 180 degrees. What quadrant do you predict my image shape will end up in?
3.
You'd say the third one, right?
Yeah.
180 degrees is always like diagonal across. So I would predict, yeah, that shape's definitely going to end up in quadrant 3. Even though it is certainly not going to end up in quadrant 3. Where do you think it might end up using this new center of rotation? Anyone want to take a prediction? Take a stab at it? Take 30 seconds with your group mates or your partner. Talk about, right here. Where is this triangle going to end up? If we turn around this new origin, where is it going to end up? Ready, set, go. All right, let's come back together. Show me on your hands without saying anything. What quadrant do you think this triangle is going to end up in here? Quadrant 8. Okay. Ooh, I see a bunch of different stuff. I see some people not doing anything. Okay, good. I see some 4. I see some 2. Let's figure it out. All right. JKL. I'm going to turn it how many times? 2 times. 1, 2, boom. I need a J, I need a K, I need an L. Now I'm going to write them upside down. All right. Here's my new pretend origin. What would my coordinates for J be if that was my origin? 2, -2. What about K? 0, -5, maybe? What about L? -1, -3. Great job. Okay, any questions on that? Perfect. Flip it around, 2 times back around. And now I'm going to plot these while somehow reading what I wrote upside down. J is at 2, -2. From this point, I'm not going to my origin. My origin doesn't exist. From this point, I'm going to go over 2, down 2. There's J prime. Great job if you guessed quadrant 4. 0, -5. Here's 0. All the way down 5. That's K prime. And L prime, -1. -1, 2, 3. There's L prime right there. You guys want to see something cool? Well, you probably don't think it's cool. I think it's cool. If I go from point J, my pre-image point, to my center of rotation, to my image point corresponding to J, which is J prime, what type of angle did I just construct? A straight angle, which is how many degrees? 180 degrees. What degree did I turn this shape? 180 degrees. What about L? Here's my pre-image point L. If I draw a point or line from L to the center of rotation to my image coordinate L prime, another 180 degree angle. So again, that's a way we can check. Like if this problem said 90 degrees and you got this answer and you did those lines, you would go, uh-oh, I went way too far, right? I'm going to let you give the last one a try on your own. You're going to rotate 90 degrees counterclockwise about the point, 1, -2. Give it a shot. See if you can figure it out. Yes, Anthony. Once you figure out number 4, yeah. Yeah.
What is it about me?
Around.
Like in this situation?
Around. If it makes you feel better, write 90 degrees counterclockwise around point 1, -2. Yeah. when we're all done, yes. We'll be done soon.
Because if you're looking at that's like where it is.
Thank you.
I might have done it.
I appreciate it. Something I couldn't afford. I like that. Hold on. Feel free to check your answer against the board real quick if you got it.
I can't wait. I don't understand. Wait, do they play K? Is there any colors?
Yours looks like a translation.
Yeah, that's what I did.
1, -2, 0, 0, 3. -1. You went 2 positive ones. Not more. So if by some rotation is the same point, it shouldn't be off to the side. It should go off to the side. Last one's wrong. Oh, right. Yeah. So let's go ahead and get it. Let's go ahead. Go ahead. I prefer to know as little about what happened to the
Like, I've never used the restroom at the school.